Hello, my name is Claire Crookston, and welcome to the Mac Academy video training series. On this particular tape, we're going to talk about how to set up, operate, and work with a small AppleTalk network within your office or within your building. What we're going to do is talk about the different definitions that you'll need to know for a network. We'll talk about some of the history so that you understand what goes on in a network, some of the mechanics about how a network works so that you can understand what's going on. It makes it a little easier to become unintimidated if you understand what's going on within the network. It's really not all that complicated or technical. We're going to try and keep it not technical. Then we'll talk about some do's and don'ts and some different things to consider and ways to administer in setting up a small AppleTalk network. As we do so, I've put together some information on a HyperCard stack to go through and show you the different things that we're going to talk about as we do. As we go to the screen, I've put together a HyperCard stack so that we can illustrate some of the points as we talk about them and learning about networking on the Macintosh. First thing we want to talk about is what is a network, just what constitutes an AppleTalk network on the Macintosh. A computer network is created whenever one computer is connected to other computers or devices such as printers, allowing users to share information or resources. A computer and printer are connected directly by cable. The printer cannot be shared by other computers. That is not a network. A lot of people think that when they have a LaserWriter hooked to their Macintosh that that's a network. It's not a network because it cannot be shared by any other computers. The computers and printers here are connected by a network cable. So there's more than one computer connected, and the LaserWriter in this case can be shared by more than one of the Macintoshes. That does constitute a network. So in its simplest form, with the Macintosh network, anytime we share a LaserWriter over a network with one or more than one Macintosh, we have a network. So in simple terms, that's what it boils down to. There's a lot of history behind networks. Most networking we started a long time ago with mainframe computers, and that's called host-based computing. That was typically a mainframe computer. They were big and expensive in the old days. They filled an entire room, and that usually did all of the calculations, all of the computing. Not too many years ago, they weren't as powerful as some of the computers we have on the desktop today, but they were expensive and filled rooms that had to be controlled with specific climates and took a lot of computer knowledge in order to run them. So they resided in one area and ran by a staff of people that understood them, and then we had what was called dumb terminals that were hooked to the host computer. All of the calculations take place over here on the mainframe. And on the dumb terminals here, we have a keyboard and a screen. They don't have any ability to compute on their own or to manipulate any of the data. That's simply where we would see data on the screen and type data in. All the computing would take place on the mainframe computer. That's called host-based computing. An example of that would be maybe a large central bank where everything's handled by the mainframe, and then on the terminals that you see where you look up deposits or enter checks, that's just entering and looking at information. Everything takes place on the mainframe computer. As computers have progressed and got smaller, we've moved towards what is called decentralized computing. Decentralized computing in its purest form still involves dumb terminals. They don't really do any calculations on their own, but we now have what's called mini computers or mini mainframes. More powerful than the personal computers that we use on our desktops, but not as powerful as some of the mainframe computers. More powerful in some cases than the older mainframe computers of not too many years ago. If we were to continue our same example of stretching this network out a little bit, this would be maybe the branch offices in a particular bank, where we still just have dumb terminals to enter and view information and tally the deposits, but all of the actual computing is done maybe at the branch on the mini computer, and in some cases that may be transferred back even to the main office onto a mainframe computer. But that's called decentralized computing. We're just moving some of the computing power away from the mainframe towards the end user. As we continue on in today's networks, we now have personal computers that are as powerful as some of the mini mainframes or even mainframe computers of not too many years ago. And the kind of computer networking that we do now is called peer-to-peer. In other words, all of the personal computers on the network are not dumb terminals now. They are full computers that have the capability of any personal or desktop computer, and all of the computers on the network are peers. In other words, they all have control and access of information and can do computing on their own. They can share information back and forth across the network, but basically on the network they're all equal. In this case we have 4 Macintosh computers. They're sharing a common laser printer, and they could also share common files amongst each other. That's a simple version of a very small one, but the concepts remain the same. More and more today we're moving towards peer-to-peer computing. As the size of the company or the size of the network grows, you may see some of the peer-to-peer level networks hooked into some decentralized networks with many mainframes, and even back to the host-based or the mainframe computers. And so what we see today is really combinations of all 3 types of computing, but most of the dumb terminals are being replaced with full desktop computers. Now remember, a dumb terminal is nothing more really than a keyboard and a screen, whereas the desktop computers have all the power to do the computing on their own as well. There are 2 kinds of network that we hear people talk about. The first one is called a local area network. A local area network is made up of computers and shared devices that are connected together in a limited area, generally a single building or an office site. So when you hook up your office in a small network, maybe 3 or 4 of you in an office, or even a building the size of a university, maybe there are several hundred computers all hooked together, but it's usually in a basic site of, say, one campus or a couple of closely located buildings. That's called a local area network, or commonly referred to as an LAN, and it's pronounced LAN. So when you hear people talking about a LAN, they're talking about a local area network. That's typically a group of computers in a close geographic area. We also have what's called wide area networks. A wide area network consists of computers that are generally quite far apart, and they typically use telephone lines, satellites, or some other long-distance connections in order to communicate. In some cases they may run lines of their own. In other cases there are companies who have dedicated lines or satellites that major companies can rent. These are called wide area networks. This is where a bank like Citibank maybe has offices all over the United States, and they transfer information all over the country through these satellites or through dedicated telephone lines. That's referred to as WAN, or pronounced WAN. Most of the ones that we deal with are local area networks, and in today's computing, with the advancement of computers and network technology, it's getting hard sometimes to tell the difference on where a LAN starts and a wide area network starts. But that's basically the difference, is whether it uses those other lines to communicate versus being hardwired together or directly connected. Well, we kind of know what a network is. Why do we want to get into a computer network? What is it going to offer for us? There are a lot of other things, a lot of services. Computer networks give people access to an ever-growing range of information, resources, and services. Now, when we talk about resources, we are talking about other pieces of hardware, a large storage hard drive or a laser printer, very expensive resources that may be used by more than one computer user. Networks increase productivity by making information available where you need it, when you need it. Shared resources, as we've talked about, is one of the items that you'd want to look at. All users can have access to expensive devices like laser printers, mini computers, or large storage devices. Shared information, not only resources, but information can be shared. All users have access to common files or information. For instance, main database files from a company, or office forms, a standard point where all the forms reside, where everybody can get at the correct forms for your office. Shared reports and projects, where you can put together pieces of information from different offices. Shared applications. All users have access to the same application software. Everyone in your work group can upgrade to the newest version of a program by accessing a shared storage disk. Also, under the category of shared applications, you may find that there is expensive custom programs that are very large for big company databases or accounting systems that may not be able to function properly on a personal computer or a desktop computer, and so those can reside in a central place, and the other computers can pull and access information from those and use that to prepare reports and to get information as they operate the business, and so the application itself may be just too large to operate on a PC. Communication. You can exchange messages with computer users in your local work group or around the world by means of electronic mailboxes, a quick form of paperless communication. There are central places across the country where you can call up on a modem and send messages. Other people can pick it up at any time. That's a form of networking. We also have remote information. information that resides at some central point that you may need, but it isn't something that's commonly maintained or operated by your office. You can use your computer to check stock prices or airline schedules through public information services, or to dial up your own company's databases for information or reports. So if you have large central storage places of information, whether they're in-house or something provided from another company, with a network you can get at that information. Well, we've talked about what a network is and why some of the benefits of networking. Why network? Now, when do you determine if you need to be on a network? That's basically the same kinds of information that we talked about in why network, but there are some questions you should ask yourself, and if the answer is yes to some of these questions, then you would probably benefit from a network. First of all, if your sneaker net is getting too slow or too old or just plain inefficient, then ask the questions. Now, I don't know if you know what SneakerNet is or not. SneakerNet is a common term for the lowest form of network. That means you've got some information you need to share with someone else in your office. You put on your sneakers, grab the disk, run to their office, and give them the information. That's called SneakerNet. If your SneakerNet's just not efficient, then ask yourself some questions. Could I share hardware? If you could benefit by sharing some hardware, such as large storage disks, laser printers, other printers, modems, other computers, then you would benefit from a network. Maybe you have one laser printer and 4 or 5 people would like to be able to print on that. Even an image writer printer, if you add what is called an AppleTalk card, can be shared over a network, or a large storage disk for your main company files. Any of those resources that are expensive enough that you can't afford to put one on each station, but it would be beneficial for other people to have access, then you'd benefit by sharing that hardware with a network. Who Has the Master is a game that many people play. If you're playing Master Master, Who Has the Master, or Oops, Now We Have No Master, then you need the benefits of a network. What we mean by that is if you've got a master file and it resides on a disk, and somebody updates the information, but nobody else can update that information because they don't have the master. They have to go get the master from someone else, and so it's commonly a question of where the master is and who updated it last. The worst case is when we wipe out the master because one person has the master file, they're busy making updates and modifications to it. Another person thinks they have the master file on their copy, they're busy making updates to that. Now neither one of them has all of the correct current information. If you replace one by copying the other to it, either direction, it would make no difference. Neither one would have all of the master information, and thus you would wipe out the master and no one would have one. So if you're trying to remember who has the master, who updated it last, then you need the benefits of a network. Ask yourself the question, do I have common files? Are there some files around the office that everyone would like to have available to them? If so, do they need to be updated and distributed easily on a regular basis? You would benefit from a network. In other words, maybe you have a lot of office forms that get updated continually, and in order to make sure everybody has the current version, you have to go around the network every day and make sure everybody's got a common or a current copy. If you have a network, all those could reside in one place. Everybody could check each day or whenever necessary, whenever they wanted to use the form, and make sure they have the current version. Those are the kinds of benefits for sharing information over the network. Do you have files that you need common access to? Now that's a little bit different than common files. Do you have files for your organization that not only need to be shared, but need to be updated or maintained by more than one person at a time? If the answer is yes, you would benefit from a network. In other words, is there a large database, maybe customer file, or purchase order files, or mailing lists, or inventory files that 2 or 3 people need to be able to update and work on at the same time? If you find only one person can work on it and the rest have to wait because they need to be in that same file, then you would benefit from a network because now they would all be able to share the information at the same time. They would all be working in essence on that same master file and could be updating individually, but all the changes would be made at the master. How about electronic mail, or commonly called email? Would you like to send messages or even files to others in your work group directly from your computer? Maybe call in from a remote site for information or files. If so, you would benefit from a network. Now here again, you may have the electronic mail files reside within your office, or you can use some of those services provided around the country where you can send messages back and forth with electronic mail. and people can pick them up at any time of the day or night. If the answer to any of these questions is yes, you would probably benefit from having a network set up in your operation. Well, what can be networked together? The answer, quite frankly, is almost anything. Shared resources. Now remember, when we talk about resources, we're talking mostly about hardware, laser printers, large hard disks, expensive resources that you can't afford to put at everybody's workstation, but everybody would benefit from. Many computer resources, such as high-speed printers, large storage devices, can be made more cost-efficient if multiple users are allowed to share them. That can be accomplished with a network. Other personal computers. A primary use of networks is to let users communicate with each other, share information, and access remote services through their personal computers. So all of the things that we've talked about, you compile and utilize the information on your personal computer. If each person in your organization is doing the same thing, if you would benefit by being able to share the information back and forth, you can hook personal computers together in a network. They don't all just have to be Macintoshes, or they don't all have to be PCs. You can mix Macintoshes and MS-DOS machines on the same network, and that's becoming easier and easier to do. We'll talk about some ways to do that easily a little bit later on. Network servers. Some main functions of computer networks, like information sharing or electronic mail, may be handled by network servers, computers with special software that provide those services. Maybe in the case of electronic mail, as an example, that's a piece of software where all of the messages reside in one place and everybody else hooks together to that server machine, it's called, or server computer, and so it controls the operations. All the other computers have access to it. That's what we mean when we talk about networking to servers. Minis and mainframe computers, computers of varying types and sizes, serve a wide range of functions such as centralized database management, file service, and network control. So we can network to other PCs. We can network as well back to the mini or mainframe computers if they require that for the applications that we're using, or if our files are so large they can't really be handled on a day-to-day basis by a desktop computer, we can network to the mini computers or the mainframe computers. You can even network to other networks. Special devices can connect together 2 or more computer networks, allowing users to gain access to information and services on other networks. Here we have Network A, which involves 3 computers, and we have Network B, which involves 3 more computers for purposes here. Maybe Network A is the accounting department, and Network B is the production department. And occasionally they need to share some information or access that. We can use what's called a bridge, and that's a piece of hardware that actually connects the 2 networks together, so we have networked one network to another network. So as you can see, we can network just about anything together with the proper combinations of hardware and software. Well, how does a network behave? Why do the things happen the way they do? To reduce it to its simplest terms, it's really not too hard to understand. Every device that might be the target of a transmission on the network, such as a computer or printer, is called a node. Each node has an address to identify it from all the others. If we use terms that we're familiar with, here we have 2 Macintoshes and we have a laser printer. Each of those items on the network is called a node because they could receive transmissions. Each one of them also has an address. We've got a computer here called Smith, and it lives at 123 Main Street. We've got a computer called Jones that lives at 15 Maple, and the laser writer we'll call Johnson that lives at 27 Elm Street. Now obviously in the computer network we don't use those kinds of names and addresses, but the concept remains the same. They're usually a little more computer-like codes and numbers and names, but nonetheless the same concept applies. Each one of them has an address that's unique to the network so that they can find and communicate with each other. They do so with a process called packets. If Mr. Smith wants to send Mr. Jones some information, a packet is prepared with all of the necessary information. So we've got the computer name and address here. We're going to send some information over here to the other computer called Jones. Now that information, in this case it would be the document, is put inside of a packet. That would be like taking a letter and putting it inside of an envelope, or a piece of information and putting it inside a package for the UPS driver to deliver. It needs to know the information about where it came from, where it's going to, And it also has to have some instructions. So when this package arrives at the other computer knows what to do with it. So it'll have instructions that you might find on a particular label, for instance, in sending a package, such as how to open it, a list of the kinds of information inside, and in some cases some assembly instructions, because all of the pieces may not show up in one box. Typically what happens on a network is it sends out information over the network from one computer, and if it were allowed to send a large document all at one time, then nobody else on the network could send any more information until the first computer got through. So what they will do typically is allow it to send out a certain number of packets, and then it gives the other computers on the network a turn to send some information, and then it can go back to the first computer and they can send some more information. So all of the information may arrive to the other computer in a number of pieces. The other computer needs some instructions on those pieces of information on how to reassemble them so that it can use the information once it receives it. But that's all that happens over a network, is it takes the information, prepares some packets, and sends it out across the network to another address. Now we get involved, though, with what is called network protocols. Network protocols are the rules that network devices must follow to successfully interact with one another. For instance, here, on the left-hand side, we've got a packet that was prepared from the computer called Smith and sent to the computer called Jones. And it had all the instructions and all the information, everything it needed to use properly, so the computer that sent it understands that information. As it goes out across the network, however, and arrives at another computer, it may look like it's in some other language. So we not only need to make sure that the proper information is in the packet, but we need to make sure that all of those instructions are in a format that the other computer can understand. Now commonly, if it's the same kind of computer, we don't need to have any kind of translation because they all speak the same language. But if we're sharing other computers or other devices, say other brands of computers, then they don't always understand the same language. So we could send them a packet, but if it's in a language it doesn't understand, it has no idea what to do with this information when it has received it. So we use a process called translators, and they work with the protocols to convert the information into a format that both computers can understand. So now the information, when it arrives at the second computer, not only has all of the instructions, but it also is put together in a language that that particular computer understands, so it knows what to do with the information once it receives that. That's where networks get a little bit complicated, is what's called the protocols. The mechanics of how they work is basically quite simple, but the protocols can be quite complicated. Fortunately for us as users, we don't have to spend a lot of time worrying about the protocols. Those are usually handled or taken care of by the people that design the networks, and for the most part it's transparent to us, the users, and so we don't really have to worry about that. We just go ahead with our normal daily tasks, and all that happens in the background, so we don't have to worry a whole lot about it. Well, there are different parts to a network, not just the packets, but there's physical pieces that make up a network on how we hook them together. We need to identify what all of those are and understand their different roles in a network. The first parts that we need to talk about are connection hardware and software. The connection hardware is the connection device that transmits and receives the packets over the network. This may be built into the computer or added in later, or in some cases it may be connected as an external unit. Fortunately, on the Macintosh, it's built into every Macintosh from the very first 128K Macintosh. The connection hardware is part of the Macintosh, so it knows how to hook together and communicate over a network. That's one of the advantages of the Macintosh, is it's what we call plug and play. That means we simply plug it in and everything works without a whole lot of interaction on our part, because it's all set up when the computer was designed to be easily networked together, much more so than most of the other computers in existence. Now there's also some network software which I will call connection software, because I don't want to confuse this with the software that you may be using, such as TOPS or Apple Share or MacServe, that we'll talk about later. That's the software that the user interacts with. This connection software is the network connection software, often referred to as the network driver. It implements the network protocols and prepares the data for transmission on the network cable. That usually all happens pretty transparent to us as the user, but it needs to be happening someplace inside of the computer. Again, fortunately on the Macintosh, that's built into every Macintosh as part of what's called the ROM chips. So all the information is there, and it's already part of the computer. We don't have to worry a whole lot about it. We simply plug them in, and the network works very easily with Macintosh. Next thing we want to discuss is network media. These are the connectors, cables, and other carriers of network signals. They're called network media. With an AppleTalk network, there's typically three parts that we need to be concerned with. There is the connectors. That's the device that comes out of the back of the computer. Connectors are part of the hardware that connects the computer to the cables for the network. They look something similar to this in Apple. And Apple provides one called AppleTalk connectors. Now when we talk about an AppleTalk network, it's made up of a lot of parts. One of the parts to an AppleTalk network is an AppleTalk connector. And that's a device that plugs into the printer port on the Macintosh, and it hooks up to the cables that you've chosen to hook your computer over the network with. Now there are not just AppleTalk connectors, there are other companies, and this is just representative here. There are PhoneNet connectors provided by another company, and there is one called TurboNet, ST connectors. They are all slightly different. They're easy to use on the Macintosh. They all hook up the same way, but they all have advantages and disadvantages that we'll talk about a little bit later on. But that's the connectors, the device that hooks the computer into the cables. The next part of the network is the cables themselves. Now this is the wiring between the connectors on each device on the network. Once we've got the connectors plugged into the back of the computer, we need the wires to hook them together. This would be equivalent to the telephone lines. That's the actual wiring that goes from computer to computer or to printer or other device on the network. There are several kinds of cable. They all offer advantages and disadvantages, and there's basically three different concepts that we need to understand in cabling. The first one is twisted pair. This is what an AppleTalk network uses. Twisted pair is more commonly referred to in AppleTalk networks as telephone wire cabling. It's a pair of wires inside of some shielding, and they're twisted. That provides equal exposure and equal shielding to interference over the network. That's where the name twisted pair comes from. And the most common reference, again, would be telephone wiring that we can use to hook up an AppleTalk network. It has a limitation in how fast information can be transferred over a network. I'll tell you what that speed is, and we'll talk about the implications of that a little bit later on. The speed of information over an AppleTalk network with twisted pair wiring is 230K, or 230,000 bits per second. That's how fast the information can be transferred. Now that sounds like a lot, but in computer terms it's really not very fast. It's much slower than the computer sends information to the disk drives, or in many cases even to the printer. The next type of cable is coaxial cable. That's familiar to most of us because that's the type of cabling that you use to hook up your cable TV. It allows a faster transfer of information. It can get up into speeds of 10 megabits per second, or 10 million pieces of information per second, or even 16 megabytes per second of information. So it transfers information a lot faster, and in many cases it allows a longer distance, but it is much more expensive to use, and it does require different kinds of connectors. When you get into some of the large, expensive networks, we go into fiber optical cable. Now, fiber optical doesn't send little pulses of electricity as the other wires do. It sends little bips of light, and the computer interprets those. Well, as you're well aware, light travels very fast, and we can send a lot of information very quickly, very long distances. It doesn't tend to dissipate like the electrical impulses do. So fiber optic cable is very expensive, but allows fast data transfer and long distance of information. The next piece of the AppleTalk network, we've talked about the cables, we've talked about the connectors. The next piece of the AppleTalk network is the application software. Now don't confuse this with the network software or the connection software. We talked about that just a few minutes ago. That's built into the computer. The application software is the user software that controls how you share files over the network. And again, there are different kinds. It depends on the amount of information you have to share and the different ways that you want to share it. which application software you would use. Three more popular ones, or just by name and use, would be MacServe, which is one of the first for AppleTalk networks, which is a very easy, inexpensive way to share some files across an AppleTalk network. There's another one called TOPS, which is a different kind of sharing of files. We'll talk about each of these a little bit later on. And then there's the one provided by Apple, which is called AppleShare. This is the application software, or the software that you would use as a user day to day in sharing files over your network. The information would go out of the connectors, transfer through the cables into the other connectors, and so all of these pieces make up the network media, or the parts of an AppleTalk network. As we talk about networks, we need to learn a little bit about network topology. Now, topology is the physical layout of the network, how the computers and other devices on the network are actually wired together. There are some common types that are used in an AppleTalk network. The more common, or the first one that operates with AppleTalk, is called a daisy chain. Now, if you look at the illustration here, you'll see 4 computers, and we have a connector out of each one of the computers, and you can see that a wire comes out of one connector, goes into the connector on the next computer. That has a wire coming out of that, goes into the connector on the next computer. Wire comes out of there, goes to the connector on the next computer. That goes to the connector, in this case, on the LaserWriter. Well, there's an open side at each end. Those are the ends of the daisy chain, and they need to be what's called terminated. The connectors have a little resistor that you clip in, and that terminates it. The reason to terminate it is as the signal goes out across the network, it needs something to terminate it at the end, or it will cause interference and just kind of echo back over the network. So it does need to be terminated. It's very easy to hook up a daisy chain, but it does have one distinct disadvantage. If the chain is broken, in other words, if one of the computers disconnects from the network or breaks down and has to go to the shop for repair, you can see that it has broken the chain, and now the network doesn't function. That's commonly referred to as the network is down. Now, parts of it may function. These two may be able to share information depending upon the application software they're using, but they couldn't send anything to the LaserWriter to print. This computer could send information to the LaserWriter to print, but it would not be able to share information or send any files to the first 2 computers on this network because, again, the chain is broken. One disadvantage to the daisy chain. There is a more popular topology, one that I think works much better. In my opinion, it's called bus topology, or it's also commonly referred to as a trunk line. Again, it's terminated at each end, but in this case we have one main line, or trunk line, that runs, say, around the perimeter of an office. Now, each of the computers simply plug in to that trunk line. And it would be much like plugging in different extension phones in your house. You have one telephone line that comes in and goes throughout the house, but all of your different extension phones just plug into that. Again, it needs to be terminated at each end. The advantage to the bus or trunk line topology is that if some disconnect from the network, in this case 2 of them have disconnected, they were either down for repairs or the people took them home to work on some files at home, you can see that it does not break the chain. The network still stays intact. Everything works just fine. So they can plug on or plug off of the network. Anybody can. They no longer have access to the network, but it does not affect anybody else that's on the network. Again, this is a very popular for obvious reasons, and it's a highly recommended topology for most cases. There is one called a star. Now, this requires a special controller. It's called a star controller, and it's another piece of hardware. The way a star controller works is a little bit different, and it does help with network traffic. Typically on a network, what happens is the computer sends out information. When you want to send a packet over the network, it broadcasts the information out over the network, and it just is available to everybody, much like broadcasting a signal out of a radio station. It's available to everybody on the network. They could all get it. If it happens to be the right address, then they pick up the information because it's for them. As you can see, with everybody broadcasting, it can very quickly jam up the network because you've got a lot of traffic out there, and so there can be some confusion and even some collisions in some cases. And so what we do with star topology is it works a little different. This works more like the switchboard in your office. When one phone call comes into the office, the main person answers that, and then directs it to the proper extension. In fact, this is actually designed to work through the telephone switch boxes that are in many people's office phone systems. In other words, this computer wants to send some information. It sends it to the star controller. The star controller sorts out whose address it's for and sends the information directly to that computer rather than just broadcasting it all over the network and impeding some of the other network traffic. That does require an extra piece of hardware, but it does make a nice setup and increase some of the performance on some networks. There is another one now that's been very popular in the MS-DOS world that is now available for Macintosh, and this is called a token ring. Now this requires some special hardware for the Macintosh itself. It's a different kind of network protocols that the Macintosh was not originally designed to handle. And so you do have to add a board or a card inside of the Macintosh. The way the token ring works is we have a closed circle, which is usually prohibited on AppleTalk networks. And it has a little token, it's called, or let's just refer to that as a carrier for the information. And when the computer here wants to send some information, it waits for the carrier to come by as it travels around the ring. When the carrier comes by, it picks up whatever information was for this address and drops off any information for this address. It then moves on to the next computer, drops off any information that was sent to this computer, picks up any information, travels to the next computer, drops off whatever was here, picks up any other information it wants to send, and so on around the network. So as the token travels around the ring, it just picks up and drops off information, so every computer on the network in a token ring has equal access, and it does in some cases improve the performance depending upon the files you're using there. So you do have the ability now to hook a Macintosh into what is called a token ring network. It's been very common and very popular in the IBM world. You can also mix network topologies. A very common growth in some offices is they set up a trunk line and get most of the computer running on a trunk line, most of the computers. And then we find in another office there isn't an outlet, but we needed to add a second computer. We added another desk there, wanted to put a computer there, or maybe a laser writer needed to be in an office that was already clear full with the access to the trunk line, and so we could daisy chain. So with the proper hardware and software, you can mix different topologies. You can mix a daisy chain with a trunk line. You can mix a star topology with a trunk line and a daisy chain. And so there are different ways to mix them together to come up with a way to wire your office together. About the only restriction on an AppleTalk network is that it can't be a closed loop like the token ring. Well, I said we'd talk about some of the differences in the connectors because that's what really determines in some cases the type of topology we can use in an AppleTalk network. AppleTalk connectors are provided from Apple. They all look very similar, but they behave a little bit differently. The AppleTalk connectors provided from Apple allow only daisy chain topology. In other words, one computer strung to the next computer, strung to the next computer. If anybody breaks the chain, the network is down. The distance for a network, and this is important that you remember this, is the distance in a network is the total feet of wiring in both directions. Now what we mean by the total feet of wiring in both directions, remember we have twisted pair wiring. That means there's two wires inside of the cable that connect the two computers together. So if we have one computer here and we have another computer here and those computers are 10 feet apart, we've got 10 feet of wire, that is 20 feet of network because we have 10 feet with one wire and 10 feet with the other wire. So we've used up 20 feet even though the computers are only 10 feet apart. So when we talk about the network distance, that's typically will be double the distance of the amount of feet of wire that's used to hook them together. So with AppleTalk, as you can see, we're limited to 1,000 feet in both directions for all of the computers to be hooked together. The Apple wiring or Apple cabling is twisted pair, but it is shielded. Now shielded means that there's a protective coating around the outside that helps stop outside interference that could interrupt some of our transmissions. Now it has its advantages and its disadvantages. If you received outside interference, you would have less problem with shielded wire, but the shielding itself absorbs part of the energy of the electrical impulses, and so the distance is usually shorter when you're using a shielded wire. Another type of connector was developed by a company called Farallon called PhoneNet connectors. That's almost become the alternate standard for AppleTalk networks. The connectors look very similar. but there is a significant difference in how they work. They allow a daisy chain topology. They also allow a bus or trunk line topology, a star topology, or you can mix any of those topologies together. And it uses regular telephone wire. In fact, in some cases, if you only have one line in your building, one line on the telephone only uses 2 of the 4 wires, and this uses the other 2. So in some cases, you can just plug it in like an extension phone right in your phone outlets and have your network operating. I don't really recommend that because most people have more than one line in their operation, or if you go to add another line, you'll start to have problems. Also, you had no control over the distance in those wires and how they were laid. And so what most people do is they just run another line. It's regular phone cabling, but it deals just with the network on the computer, and I highly recommend that. But it's very inexpensive as opposed to the shielded wire that Apple uses. Another advantage is it is unshielded. Now again, the disadvantage is it is a little more susceptible to interference. But with the lack of shielding, the distance is now 3,000 feet. So we have tripled the total amount of wiring that we can use in hooking up our network. By adding the other topologies, it becomes a lot easier to put together a network, because as you start to run wires around a building and up the walls and around corners, it doesn't take very long to use up 1,000 feet of wire, or even 3,000 feet of wire. Regular standard phone wire is all that uses, so it's inexpensive to do. There's another connector that's becoming quite popular, and I use these as illustrations to point out the kinds of differences you should be aware of, not just the different prices, and this is by no means a complete list. One called a TurboNet ST connector. It looks very similar to the others, but you'll see 2 little lights on a kind of a smoked plastic case. Now the advantage to the 2 little lights is whenever the computer is sending or receiving information over the network, those lights blink. So it's very easy to see if there's a bad connection in your network. That doesn't happen with either of these other 2 connectors, so if there's a problem someplace, it's kind of hard to trace down. If there's a problem with one computer communicating over the network with the TurboNet ST connectors, it's very easy to just look at the connector and see if you've got a connection problem. And so it's easy to find some of the problems in the network. There are some other advantages to that. It allows all of the topologies that the PhoneNet does. It follows the same protocols as the PhoneNets that were established by a company called Farallon. But it does increase the distance to 5,000 feet. So we do get a little bit more distance, and it uses the same unshielded twisted pair standard telephone wire, and they are self-terminating. On the daisy chain, remember, we had to have a terminator at each end. And also with the PhoneNet connectors, we had to use terminators. With the TurboNet ST, they are self-terminating at the end of the daisy chains. However, if you do have a trunk line, you still need the terminator at each end of the trunk line. But other than that, you don't have to worry a lot about if you have the proper terminators and where they need to go. That's all handled by the connector itself. So as you can see, there's more to consider than just price when looking at the different connectors. And there will be others out that have different features and different advantages. So make sure you're aware of them all as you pick them, because they can affect how you set your network up. There are other devices that we need to be aware of as we start to utilize a network. First one is called a repeater. As you're well aware now, we've got 1,000 feet of distance with an AppleTalk connector and AppleTalk cabling. Well, you wouldn't take long to use up 1,000 feet of wiring hooking together a building. What happens if we need more computers hooked into our network, but we've used up our 1,000 feet of wire? Then we add a device to the network called a repeater. And what the repeater does is it picks up the signal and retransmits it, thus doubling the length of our network. So now we'd have 1,000 feet over here on the left side. The repeater would rebroadcast the signal at full strength so it could go for another 1,000 feet on this side. Now I'm using the AppleTalk as the example here with 1,000 feet. This is still one network. This is a network of 6 computers, not 2 networks of 3 computers. That's 6 computers in one network, but the repeater allows us to keep increasing the distance. If we had enough repeaters, the theoretical limit on the new AppleTalk networks is about 64,000 nodes. So as you can see, you're probably not going to run out of addresses on the network. You'll run out of distance much sooner. We can hook other networks together, as we talked about a little bit earlier. This is a piece of hardware called a bridge. Bridges allow information to flow between the networks, but to the user it appears as one network. Now let's use the example we did before. On network A here, we have the accounting department. They've been networked for some time and they share accounting files and do their reports and information. On network B, on the right side over here, we've got the production department. They're busy getting their product out, but they need to access information and send reports to network A. With a bridge, we can actually hook the two networks together, and it's almost transparent to the user, but from a hardware standpoint, bear in mind these are still two separate networks, unlike the repeater that just extends the distance of a single network. It'll look almost the same to you, the user, but from a hardware standpoint, there's a noticeable difference. That's called a bridge. There's also a device called a gateway. Many times we need to hook our Local Talk or Apple Talk networks, that's Apple's new name for Apple Talk is Local Talk, into another network, say Ethernet or EtherTalk, or some of the other types of network protocols that are available out there. A gateway serves as a translator between different kinds of network protocols, allowing them to share information. So with a gateway, you can connect your Apple Talk network or your Local Talk network into another kind of network that may be in use for your mainframes or your mini mainframes, or even in the IBM world, say a token ring or an EtherTalk network. They can be connected through what is called a gateway, so they can share information. You also have to have translators with the gateway. Sometimes they come with the gateway, sometimes they don't. But that's really the intent, is to allow you to mix those different items together. Now, we've used a lot of terms as we've gone along here, and so there are some definitions that you need to be aware of as you start working on a network. Some of them I've used, I've tried to explain them as I go, but there are a lot of others. So let's go through some definitions that are quite common to working with an Apple Talk network. The first one is terminal emulation. Terminal emulation is software allowing your computer to send and receive codes as if it were a terminal of some other type. By terminal, typically we're talking about some of the dumb terminals, and there are several different kinds. With the proper software, you can have your Macintosh behave like one of those dumb terminals, and it can share information just as the dumb terminal did over a network with, to say, a host or a mainframe. Once it has that information, then it can go ahead and work on it on its own because it is a full computer. But terminal emulation is software allowing us to make our computer behave like a different type of terminal. A node. As we've talked about earlier, a node is any network device that has a network address. So each computer on a network would be a node. A printer on a network would be a node. If you had a network modem that was designed on the network to share with other devices, that would have its own address. That would be a node. So any device that has an address of its own is a node on the network. A file. This is common to computer terms. There are lots of kinds of files as we talk about working on the Macintosh, but for purposes here, a file is any information that can be saved to disk, printed out, or transmitted over a network. That's a file. A volume, another term we're familiar with on the Macintosh. A volume is a general term referring to a storage device, a source of, or a destination for information. Now, in Macintosh terms, typically when we talk about a volume, we're talking about a disk that shows up on the desktop, or we're talking about a folder as a volume. Some networks use folders for volumes, some networks use disks for volumes, but the general term is the same. It's a storage place for information. A host. We talked about host-based computing. Host is a multi-user computer, such as a mini computer or even a mainframe, that serves as a processing unit for a number of terminals. In other words, the actual computing takes place on the host. Other computers can send and receive information from there. A server. A server is a network device, usually including software, that delivers some kind of service to network users. Now, an example of that would be maybe electronic mail. All of the addresses, all of the mailboxes, let's say, or the messages are actually stored on one computer called the server, and that then provides that service to all the other people on the network. That's called a server. A client is almost the opposite of that. A computer receiving services from a host or a server computer is called a client. A user is anyone accessing a computer node for sending or receiving information. Now, the user is you. Your computer may be a client, it may be a server, it may be a host, or it may be a combination of those. But you yourself are the user as you access and send information. Packets we've talked about as we explained how a network behaves. A packet is a unit of information that has been formatted for transmission on a network. Traffic, much as its name implies, is transmissions traveling across the network. Now, one of the important things to remember when you're working in your network is that it behaves much like a freeway system would that's connecting different cities together or different parts of town. It's connecting different computers together for information. Well, the more information you have transferring over this network, the more traffic you have. And you can get jam-ups and traffic jams and even collisions just like you can on the freeway system. And so as you lay out your network, we'll talk about some ways in the Mac environment a little bit later on, it's well to give some thought as to how information has to be shared, which computer has to be in contact with what other computer more frequently, so that you can kind of control the flow of traffic, much like a traffic engineer, so that you can kind of minimize those rush hour jam-ups that can happen on a network just like they do on the freeway. So traffic, just think of it that way, and it'll make a lot of sense. Collisions occur whenever we have too much traffic. Collision is when two packets of information traveling across the network collide. That usually forces them to be retransmitted. Most computers have a way of determining whether the information they sent was received or not, and so if there's a collision, that destroys the information and it has to be retransmitted, thus slowing down the network. Published. Published is any file made available to users over a network. Now remember the file definition, that's information such as a report or a newsletter or a form for your office, anything like that. So any file that's made available to other users over the network, that file is called published. Mounted. Mounted we refer to in Macintosh terms from the Finder when a volume, now again that's a disk or in some cases a folder, is recognized by a computer and placed on the desktop. In other words, when you're in the Finder, if that shows up on the desktop, that's what we mean by mounted. That's now available to your computer. Multi-user. Multi-user refers to software that allows more than one user to modify information at the same time. Now, even though many programs on the Macintosh allow us to share information over the network, the software wasn't designed for more than one person to be accessing that information at the same time. So while one person can be modifying information, typically anybody else can only read or view the information, but they can't make modifications. Multi-user software is special software that is designed to be used over a network so that more than one person can be actually modifying the information at the same time. And with most network environments, you're probably, if you have the need for a network, you're going to want some type of multi-user software. So don't think that just because you've hooked together in a network, that means that all of you can now have common access to a file. That only happens with software that's written to allow that. That's what we mean by multi-user. Access privileges. Access privileges are different levels of password protection placed on a file or volume. Maybe the accounting department has a lot of information that's sensitive, like personnel files, even though it needs to be published over the network, so maybe the administration can get at that. They don't necessarily want everybody on the network to have access to that information. So with most user software on a network, you can use different levels of password protection or access privileges so that only certain people can get at certain pieces of information, even though they're published over the network. Locked. Locked is a file that can be read from but not modified. We also use the term locked when we talk about disks or volumes. A locked disk or a locked volume, we can look at the information and view it, but we can't make any modifications to it. That can also be used in talking about files. So we can lock files, we can lock volumes, we can lock disks, so that we can view information, but we can't make any changes. Read-only is another way of maybe saying the same thing. A file or volume that can be read but not written to. Essentially the same thing as locked. Usually read-only happens over a network, depends on how it was published, whereas locked is something that we physically do by going to the Get Info box and locking it, or in the case of a disk, actually using the Write Protect tab to lock the disk. One-writer. One-writer means a file is published such that it can only be modified by one person. Other people can read it, but only one at a time can make modifications. Typically, whoever opens the file first has the opportunity to modify the file. Anyone else can view it but not modify it. A lot of the software written for AppleTalk networks to work with Apple Share. were written such, if they followed Apple's protocols, so that even though it's not true multi-user software, at least one person can make modifications while other people view the information. Once that person releases the information, then whoever opens it up next has the ability to modify. So everybody over a network may be able to modify it, but usually only one person at a time, while other people can just read it. And so that's what we mean when we talk about a file being published one writer. Many writers is typically software, again, that's written so that more people can use it at one time, multi-user software, a file that can be read and modified by more than one user at a time. So remember, if you want to have a file that's published and available so everyone can modify it, it also has to be created or be software such as FileMaker or a lot of databases that were written such to be multi-user. Then you can make them available to many writers at the same time. A dedicated server is a network device used exclusively for providing network services. Now, the more common dedicated server is the Apple Share software requires what is called a dedicated server. That means you have one computer that does nothing but operate the network. Nobody else can be using that to do their personal computing. It is completely dedicated to running the network. That's what we mean by a dedicated server. Apple Share software requires a dedicated server. For many people, that's prohibitive because you don't want to give up the price of one computer in order to have it dedicated to just running the network. As your network grows, you may find that the speed increases and the file management are such that it's actually an advantage to have a dedicated server. But that's what the term dedicated server means. One device, usually a computer, set aside exclusively for operating the network. A distributed server is a little bit different than that. That's a device that can serve both as a server and a client at the same time. In other words, you may have a distributed server network where everybody on the network can publish information, make it available to other users, and at the same time they can be accessing information that some other user has published. So at the same time they're providing services to the network, they're also receiving services from a network. And so that's what we mean by a distributed server. Background. Background refers to operations that are running transparent to the user. Those are typically called background operations. Many people are familiar with print spoolers. That means that the document has been spooled to the disk and the printer is busy printing that document while you're going back to work on some other document on your computer. That printing is then taking place in the background. A lot of the communication software allows you to call up an information service like CompuServe, and you're going to download some files or receive the information from that mainframe computer. That can happen in the background, transparent to you while you're busy working on another document. So when we talk about things happening in the background, that's what we mean. It's basically transparent to the user. It happens whether you're busy tending to it or not. Modem is a device used to convert computer data into a form that can travel over telephone lines. The name comes from modulate, demodulate, and that is an external device that prepares packets, in a sense, so that you can transmit information over telephone lines. KBS, or kilobytes per second. MBS is millibytes per second. Kilobytes per second is how many thousand bits. The K stands for 1,000. It's actually 1,024. How many thousand bits per second travel across the network line. So we're referring here to the speed of a network. How fast does it transfer information over the network lines? Now remember, again, with AppleTalk, the network speed is 230 kilobytes per second, whereas with some of the other types of networks, say EtherTalk, it's as high as 10 megabytes per second, which is significantly faster in computer terms. Well, there are different types of Macintosh networks that we can hook together and start to get operational in ours. I'm going to start at the lowest level, and then we'll kind of build from there in terms of complexity and different ways that information is shared. The simplest Mac networks were done just to share a laser writer among a number of Macs and other PCs. This requires only the connectors and the cables. In other words, if you have Macintoshes, AppleTalk is already built in. That was part of the Macintosh hardware. And the laser writer was also set up to communicate over the network called AppleTalk. As long as they are physically hooked together with the connectors and the cables, these computers can share information with the LaserWriter. And so it doesn't require any other kind of software or anything else. If they're physically hooked together, you can all share printing on the LaserWriter. So that's the simplest form of Macintosh Network, and probably the place most people start as they network is simply sharing a LaserWriter. Now, if we move up a line, there are different types of software being written now. With multi-user software such as FileMaker, you can access open files from within that program with no other network software. This again requires only the connectors and the cables. Now in this case we've got the FileMaker logo on the screen to illustrate that each one of these 3 Macintoshes has the program FileMaker. That's the database that's in use to share customer files or inventory files or purchase order systems, mailing lists, things like that. Well, FileMaker was written not only to be multi-user, but it was also designed such that the files can be shared across the network or AppleTalk with no other software to control how that transfer takes place. It's all accomplished from within FileMaker. So if you just have some common data files that need to be shared, and those files are going to reside in FileMaker, there are some other software that works this way. There's more appearing on a regular basis. But if that's the situation you have with your software, again, you don't need any other server software, just the connectors and the cables to hook the network together. It's kind of a step up from just sharing the printer. Next step from there would be maybe some server operations. Say electronic mail usually requires one computer to act as a server. You can send messages and files. This again requires only the connectors and the cables. Let's say the electronic mail software resides on this computer and it provides the services to the other computers, but it's all handled from the server, and so they don't need any other special software. Again, only the connections and cables. So as you can see, even without a lot of software, you can get a lot of network services by putting together just the physical network itself, the connectors and the cables. We haven't even got into Apple Share or TOPS or MacServe yet. We've been able to share a lot of things. As we continue to move up the line in sophistication of sharing, then we get into some of the server software. I'll talk about 3 of the more popular ones right now because they all take a different approach to sharing files on an AppleTalk network. And again, this is by no means a complete list of all the options available out there. With network software such as MacServe, which was actually the first of some of the software for the Macintosh, you share volumes from a host hard disk across the network. Now, MacServe is very inexpensive. One computer becomes the host computer. That means it's going to provide services to the others. Well, in this case with MacServe, the service it provides is it can have volumes set up on this host disk so that the different computers can mount those on their desktop and have access to that information. It also has the ability to take an ImageWriter printer that does not have an AppleTalk card, attach it to the host print computer, and the other computers can share that host printer. So it provides a very low level of file access. It's a good, what I call workhorse product. That means it's very stable, it's been well maintained. It doesn't have a lot of fancy features, but it does get the job done if you just need to share a couple of files and maybe a printer, but you don't want to spring for a LaserWriter. Now, typically you buy one set of MacServe software for a host. You can have any number of hosts on a network, and typically a host can service 4 or 5 different computers. So it's a very inexpensive way to get started on a pretty simple network. And it's a good, stable product, but not a lot of fancy bells and whistles. Move up in complexity a little bit and a few more features, we go to one called TOPS. With network software such as TOPS, you can share files from any hard disk across the network. Everyone on the network is both a server and a client. Now remember, this becomes a distributed file server. In other words, we have a copy of TOPS on each of the Macintoshes here. That means that any file on their disks can be shared across the network. If they would like to not have them shared, they don't have to. They can publish anything they want. They can unpublish it any time they want. Anything that is published is available across the network, and there are some levels of password protection. It's very fast for networking. It allows you to distribute the traffic a little bit, and it's a good, stable product. It works well on the Macintoshes. It also is an excellent product for mixing Macintoshes and PCs in the MS-DOS world. They have an option for MS-DOS, so you can share files almost transparently between the different kinds of computers. That's software such as TOPS. It's a distributed file server. With Apple Share, this is the one that Apple provides. Very elegant, nice interface, smooth operation. It provides software, all the software network files reside on the server's hard disk. The server functions only to control the network. This is a dedicated file server. That's the one disadvantage to Apple Share. is that it does require a dedicated server. In many cases you'd want a fairly fast machine like an SE30 or a Macintosh 2 because it's going to do a lot of work running the network, and it really should have at least 2 megabytes of RAM with it, and you're going to need a fairly hefty hard disk, and so it can be a fairly expensive computer. But all of the network files reside on this computer, then they're available to other computers over the network. So the advantage is it handles the file management very easily. One of the disadvantages is it now forces everybody on the network down to AppleTalk speed. Remember the slower speed of AppleTalk. If this computer could access information on its own hard disk, it can do so significantly faster than it can access information over the network. So the one disadvantage is it forces everything across the network back to AppleTalk speed, which makes it seem a little slower. But you can share applications and files, and it's a very nice interface. One of the setups that works very well is to mix some of the different types. One of the favorites I have is called TOPS and AppleShare, mixed on the same network, allowing heavy use files to reside on the nodes that need them. The lesser used services reside on the server. Let me give you some examples to illustrate that. We've got 3 computers here on the screen. Let's say the AppleShare server houses most of the common customer forms that need to be accessed not on an all-day long basis, but every day they need to check for the latest versions, maybe put a copy on their own disk. The electronic mail is housed there, all the mailboxes, so while the server's running, all the electronic mail is available to everyone else. Let's say this computer in the center is for a reservation system in an operation that had a lot of people calling in to make reservations and a customer list that was growing on a regular basis. And this other computer over here is maybe in the same network, and that provides all of the fulfillment or all of the products that need to be shipped out. So what we have is we have a heavy file used for shipping. We have a heavy file used for reservations, and we have some lesser used files that need to be available to everybody. By mixing AppleShare and TOPS, now remember AppleShare is a dedicated server, but by putting TOPS on the other nodes, they can be a server and a client at the same time. What this allows us to do is distribute some of the workload around the network. Let's use reservations for the example. That's the one in the center. On this reservations computer, the person that runs that file has to literally live in that file all day long. They spend all day working in that file, accessing names, adding new reservations. Other people on the network need access to it on a regular basis, but they don't spend all day in the file. They just need information for reports or tallies or maybe an update of a phone number, an address, or something like that. Well, if we were strictly on an AppleShare network, that would now force this main customer file to reside on the AppleShare server so that this person running reservations would be forced to spend all day at the slower speed of AppleTalk to spend their time in that file just so it was available for everyone else. Let's say this computer on the right-hand side is for fulfillment, as we talked before. That's a large file also. One particular person that does the fulfillment needs access to that continually. Other salespeople that want to do reports or quick updates need access on a regular basis, but they don't need to be in the file continuously. Well, the same thing applies here. If we were only on AppleShare, that would force this large heavy-use database for this person back onto the server so that it was available for everyone else. And so we now have these 2 computers that have heavy use in those files slowed down to the slowest possible speed, which is the network speed, in order to access the information. By mixing AppleShare and TOPS, we put TOPS on each of these. Now remember, they can be servers and clients. That means this computer that does fulfillment has the main customer files for fulfillment. The person that works in those files all day long now has the benefit of working at full hard disk speed, which is significantly faster than network speed. They can publish the file so it's still available to everybody else on the network that needs to access it infrequently, but on a regular basis. The same thing for reservations now. Reservations has the file on that computer that the person has to spend all day in, operating at disk speed for that person that spends all day in the file, and it's published so that the other computers have access to the information when they need it, but they can live with network speed because they don't spend all day in the file. Some of the other services like electronic mail that just need to be available all the time, that are not so intensive for speed, can reside on the central server. And so that makes a nice mix by mixing TOPS and AppleShare, and whatever topology suits your purposes, and it's an easy way to distribute the load around the network. And that works very well. Gives you some of the strengths and advantages of both of those. Well, we want to mix Macs and PCs on our network sometimes, so we need some ways to do that. Now, there's some rules that you need to follow when you're mixing MS-DOS computers and adding them to an AppleTalk network. First of all, we need an AppleTalk card. Remember, AppleTalk is a product provided from Apple so that we can network Macintoshes together very easily. Well, a lot of people want to share a laser printer or some other Macintoshes with a network that's already established in the MS-DOS world. So the MS-DOS computers need to be able to understand AppleTalk protocols. An AppleTalk card, or board, some people call it, must be added to the MS-DOS computer, allowing it to understand those AppleTalk protocols. So there is a piece of hardware that has to be added to the MS-DOS computer so that it can understand AppleTalk protocols. Then we need the network software. We need the MS-DOS versions of the network software that you want to use, such as TOPS or AppleShare. Now, MexServe isn't available for MS-DOS, but TOPS is and AppleShare is, so that we now have the PC version of those so that they can understand and share files in the same language that we want to understand and share files on the Macintosh. So that's the actual sharing, the user software. Now, just because we can get the information from one computer to the other, if you remember back when we talked about translation, we've got to get it into a format that the other computer can understand. It doesn't do any good to send somebody a package that's in a foreign language that they can't understand or utilize. So we need what's called file translation software. The network can now send and receive packets over AppleTalk. However, the information now needs to be translated into a form the MS-DOS computer can understand. Now, the common one provided by Apple is the Apple File Exchange, and there are some others available. MacLink Plus has a lot of different translators so that we can take the information from our Macintoshes, get it into a format that the PC can understand, and we can get information on the PCs into a format that the Macintosh can understand. Remember, the AppleTalk card has to deal with the protocols, but once we've got the information there, the file translation software handles all of the translation for us. I also found it's a good idea if you're mixing MS-DOS computers and Mac computers over a network to use what I call counterpart software as much as possible. That means if you're in the Macintosh world and you've been using Microsoft Word for the Macintosh as your word processor and you're now going to add some PCs into your network, it's a good idea if you have them use Microsoft Word for the MS-DOS computers so that you're both using Microsoft Word as your word processor. That eliminates the translation because those will each read and write each other's files into a format that can be interpreted by either computer, and you'll lose very little by way of formatting. Same thing applies to, say, your spreadsheet. If you're using Excel on the Macintosh, use Excel on the PC computers. That gets rid of the translation. If you find that maybe you've been using WordPerfect on the PCs, then maybe you should use WordPerfect on the Macintosh. But use counterpart software as much as you can. It makes it a lot easier on the user to transfer information back and forth. There are some network do's and don'ts that we need to work on. Just some kind of rules of the road when you work on a network. Make sure everyone on the network uses the same version of system software and printer drivers. That means all of your system software in your system folder needs to be the same version. Now, each of the system files, the Finder, Multi-Finder, and especially printer drivers like LaserWriter, LaserPrep, FontDA Mover, all of those need to be the same versions for all of the computers on the network. If not, it will drive your network crazy. Now, Apple says there are a few system versions that you can mix. My recommendation is don't mix them at all. Use the same one if you can. Never ever mix printer drivers. Make sure everybody on the network is using the same versions of the printer drivers. Ideally, you should have the same font set or the different type styles. That way, as you create documents on one computer, carry those to another computer, all the fonts will be there and you won't have problems as you start to print. So you will find that if you can share the same font set on all of the computers, then you'll be able to share documents and it won't matter which printer they were printed on. You'll still have the information intact. In fact, one step farther on that I would recommend is that you not only use the FontDA Mover and install the same fonts in all of the systems over your network. One next step better is to actually set up one system, install all of the fonts and desk accessories that you're going to have as your network set, and then actually copy that system onto each of the networks, and each of the network nodes as their system. The reason for that is even if you have the same set of fonts, depending upon when they were installed, the FontDA Mover may have given them different ID numbers inside of the system. Some programs refer to fonts by their name, other programs refer to them by their ID numbers. If you set up one system, then copy it onto all the other systems in your network, it may be a little more work initially, but now you have ensured that every system not only has the same set of fonts, but every system has the same font ID numbers, and you'll eliminate a lot of printing problems when you do that. So again, make sure they all have the same set of fonts. Best case is take one system, set it up, then copy that system on all the computers so they also have the same font ID numbers. That works very well. Also watch what is called system overhead, typically referred to as the system heap. Now, unfortunately, that's becoming an increasing problem, and it still is not addressed in very many places. The only company I have found that really addresses what is called the system heap is a company called CE Software that does QuickMail. They also do a program called Disk Tools and some other very good utilities for the Macintosh. What the system heap is, I'll put it in as simple terms as I can so that it isn't technical, is on the Macintosh, when the computer starts up, it takes a certain amount of RAM memory and it sets that aside for the system to use. The rest of the available RAM memory is used by the programs as they operate. Well, as you open up desk accessories and as you add startup documents like TOPS networks and electronic mail, some large desk accessories, all of those require more system memory. Well, when Apple designed the system, they set aside a certain amount of RAM memory that loads for the system. It also sets aside what I call a slush fund. In other words, it says the system gets this much memory, you can have this much more for running some of those other operations. Well, in today's networks, it's very easy to use up all of the slush fund. A quick way to tell if you've done that is return to the Finder, go under the Apple menu to About the Finder. And if you can see that the system memory, the bar graph is completely blackened out, that means you're using up most all of the system memory. You've got very little slush fund to play with. And you'll find that most crashes on a computer are a result of just memory problems. So if you can increase the system heap, in other words, if you can increase the slush fund, now the system gets this much memory, it's got a bigger slush fund to play with for running things like network software, and then the programs get the remaining memory. It leaves a little bit less available for programs, which can be a problem on some of the machines with only 1 megabyte of memory, but you'll find a lot of your network crashes and problems disappear. The only program I'm aware of that does an excellent job of this is provided from CE Software. It's called Heap Fixer. Comes with QuickMail. It's also available. I think if you call and ask them, they would get you a copy of it. And it's an easy-to-use little utility that allows you to assign a larger system heap. There's some instructions that's very easy to use. And if you increase the system heap a little bit, you'll find a lot of your network problems disappear. They also have a version of that that comes with a program called Widgets, which is part of their product called Disk Tools. And it allows you to adjust the system heap also. There may also be some in the public domain, but those are about the only ones that I'm aware of. And I did find that when I increased the system heap on most of the network computers in our network, that most of the crashes and the problems on the network started to disappear. And so do pay attention. Don't get carried away on a network with lots of little startup routines and sounds, all of those things that eat up RAM memory. You'll have a lot of problems on a network. Remember, when you're all by yourself, you can do about whatever you want. But when you go into a network, everything you do affects other people on the network also. So do pay attention to what I call the system overhead. Try and not get too many things happening with the system any more than necessary. Another rule, do not share applications over the network. A common way that people set up their network is they buy one copy of Excel, Word, and FileMaker, they put that on the server, hard drive, and then everybody else shares the applications over the network. That means when they want to create a document, they're forced down to network speed for the instructions the computer gets from the application and for the document preparation itself. Now remember, network speed is the lowest speed basically that your computer is going to communicate. Well, if you understand how the computer accesses instructions over a network, not even over a network, but just instructions, when you are in a program writing a letter, say in your word processor, the system instructions need to be accessed on a regular basis. The program, the word processor instructions need to be accessed on a regular basis. The document needs to have access on a regular basis. Well, what the computer does is it puts most of the document into RAM memory, so it doesn't have to access the disk in this case, let's say, near as many times, or if it's across the network, it doesn't have to access across the network as many times. What the computer accesses most frequently is the application itself, the word processor, the spreadsheet, because it doesn't hold many of those instructions in its memory. And so what happens when you share the application across the network? You have now taken the product that the computer needs to access the most frequently and put it at the lowest possible access speed. And it becomes virtually unworkable, in my opinion. It makes the network very slow. Now, I know sometimes with school situations and some setups where they have to have that, then speed is just something you're going to have to live with. But what needs to happen is you need to have everybody with their own copy of the applications. That way the system resides on a disk in the computer. The applications reside on a disk in the computer. It can access those instructions much faster than it can over the network. So all that happens at disk speed, I'll call that. And the only thing that's slowed down to network speed is the document you're creating itself. And so it's much faster network if you can do that. So everybody on a network should have their own copies of the software. That means that every computer should have its own software and just share the documents across the network. If you've got different software on the different computers, they should also use the same version numbers. In other words, if you're on XL 2.2a, then everybody else should be on XL 2.2a. And throughout all of your software, just like system software, make sure everybody's on the same versions. Then you aren't going to have problems with the documents when you try to print or go to open them if they were created with different versions across your network. Another common mistake I think that people make is they leave network files open when they're not in use. Some files keep accessing the network even when they're not in use. Some programs, particularly databases, which are very common to share across a network, are what is called disk-based. That means that the computer constantly accesses or writes information to the disk because the amount of information that a large database deals with is more than could reside in RAM memory. Well, a lot of those programs are written such that they continually access the disk as long as the document is open. So if you open up a document on your computer and then go to work on another document, even though you're not using that document, if that document resides on another computer over the network, it's now accessed through the network, it's open on your computer, even though you're working on another document, your computer keeps checking to see if there's any changes on that document. And now it has to access that document's disk over on the network computer, so it does it at network speed. That increases network traffic, that slows everybody down on the network, and it's for a file that you've kept open just because you're going to get in it a half an hour from now. It only takes a few seconds to open a file. So once you've got the information you need, as a courtesy to everybody and to increase the performance on your network, close the file down. If you need back in it an hour later, open it back up again. If it's something you need access to all day long, but you just need to reference things, maybe put a copy on your disk and then access the copy, but the master remains closed, so you don't have files left open across the network. So don't leave network files open when they're not in use if you can avoid it. If you need to, make a copy for reference so that you have a copy on your computer you can refer to throughout the day. Now, one caution if you do that, use a locked copy or change the name. If this is the master file over here on the network and you've got a copy on your disk for reference, you don't want to accidentally update your reference copy because those changes would not take effect on the master. So identify it some way if you do that, either by locking it so it couldn't be changed or changing its name or something so that it's obvious that's just your reference file. But try and avoid leaving files open across the network except when you need to. That'll help your network traffic. You need to develop a good set of rules for your network. Then train everyone on your network what the rules are. Remember, when you live in a house out in the woods, you can do about whatever you want to. Being on a network is like moving into a condo. Now, for the benefit of all, there must be some rules to live by. There are some things that you need to think about when you get into setting up your network. First of all, how are files to be opened and closed? When you're all by yourself on your computer, it doesn't really matter. You can open and close them about any way that you want to. Once you're on a network, it does matter how the files get opened and closed. Some of the multi-user software, the person that opens it first has faster access to that file. And so if it's one that's the case, then maybe the person that has to do the most entries into that file maybe should be the one that opens it first and the others open up after that. So it can make a difference on a network, even how you open and close the files. So determine if your software is going to gain anything by opening in a certain sequence and make sure that happens. Where in the topology should the master reside? In some cases you can distribute network traffic around the topology and help the traffic flow. So determine where the master should be and what computer that should be on to try and distribute your traffic flow as much as you can. Who is the network administrator? Even if you have a network with only 1 or 2 Macintoshes in it, somebody needs to be in charge of the network. How it's hooked up, make sure that it's running, if the files are backed up, sets up the network rules, and just make sure the network operates. Somebody needs to be in charge of that. In a small company, it likely isn't going to be a full-time person. In some large companies, it's a full-time position called a network administrator, and that's their job, is just to run and maintain the network. But even on a small one, you need to identify somebody that's going to be kind of in charge of the network and see that things operate the best possible way. How are updates to be handled? Is the network administrator going to go out and update everybody's disks? Or is the updates going to be put on the server in a central file, and it's up to everybody to get the most current versions on their own? I'm not saying one way is better than the other, but it is something you need to think about so that you can make a decision so that everything happens the way you'd like it to on your network. How about backing up? Now that all the files reside on a network server in some cases, everybody kind of figures out that, well, I don't want to back those up. We'll let the network administrator back those up. Network files need to be backed up. They're probably very valuable, and you need to determine how that's going to happen. Is everybody going to back up their individual disks? Are they going to back up to a network volume, and then that network volume be backed up by the network administrator? Decide what's going to be best for you, and make it as painless as possible so that it happens, and then see that it does happen on a regular basis. Anything that matters better be backed up. What computers must be started up first? If you have a central server that you want to have 24-hour access to for some kinds of electronic mail, that may need to be running all the time on a continual basis. Other times you may have a central computer that houses maybe the electronic mail. Well, if somebody comes into the office and turns on their computer, electronic mail is not available till that host computer or server computer is turned on. So in some cases it matters what computers need to be started up first before all the services are available to everybody else on the network. So you need to think about those things and come to some decisions and set up some rules for your network. Who has access to what and when? What files do you want available over the network? When will they be available? Is it something that needs to be available every day? Is it a weekly report that everybody needs to update on a weekly or a monthly basis? So determine how your network's going to operate, what files reside where, when they're going to be updated, all those kinds of things. Who has access to the accounting files or the personnel files, and password protect them to whatever level is appropriate. Virus protection. Viruses are something that need to be considered. They're a real threat, and on a network, it's just like having a cold in a room full of crowded people. It spreads very quickly. It's devastating enough if you get a virus on an individual computer and it raises havoc with some files. But if you get a virus in a network, it can spread throughout the network very quickly. And so determine what you're going to do for virus protection, what kinds of programs you're going to use, who's going to be in charge of seeing that the computers get checked on a regular basis, who's in charge of removing the viruses if one occurs. All of these things that you really didn't have to think about when you were on a computer all by yourself are things that need to be decided when you start to live on a network. One last one that I do always like to cover is to develop a standard list of all names for fields in a network database. What many companies do is all the individual users start to set up their database or customer files, and their field names may have names like first name, last name, company, street, city, state, zip, home phone, work phone. The next person in the office is setting up their customer files, and they name them F name, L name, company address, city and state are abbreviated, phone and office phone versus home phone and work phone. Now what happens if you need to merge this information together or to combine your files over the network is that these field names don't match the field names over here, and when you want to do an input, it isn't going to work correctly. So what you need to do is come up with a set of field names for your network or your operation that's the same, and everybody uses the same ones. If we're going to use first name and last name, then everybody uses first name and last name. Develop a list of approved field names for all your company databases. Now it might be a rather lengthy list because there are a lot of fields one department may need that other departments don't need. But everything should come off of that list. That way, when everything is set up on your files, if you want to do an import or an export automatically from one database to another, or from one list to another for different reports or for accounting purposes, all the automatic imports and exports work because all the field names match. And then consistent data entry for your customer databases. Are you going to use middle initials or not use middle initials? Those are the kinds of things you need to think about. We've covered a lot of ground here as we talk about networks, and we've done a lot of things that you need to think about. Macintosh networks don't have to be complicated. Fortunately, the people that write the software and establish all the protocols have kept most of that transparent in the background so that we as the user don't have to get involved with all the technicalities of a network. Talked about the concepts that are involved with a network. If you can understand and remember the concepts, learn some of the differences between the different types of connectors and cables, understand the different topologies, determine which topology is going to work best for you, which type of file sharing you need, and then start a network that's workable and that you understand, and then you'll grow with it. As your needs grow and as you see the advantages of a network, you'll find that there's a growing time that takes place too, and if you'll kind of grow with your network, who knows, maybe one day you can be the network administrator in your organization. Thank you for joining us on this tape in the Mac Academy training series. Look forward to seeing you on some other tapes in the future.